Hi, in this video, we will discuss how to perform the decibel addition, subtraction, as well as the decibel averaging. In this problem, one music instrument can produce the sound intensity level, which is L capital I, equal to 80 dB at 2 meters away from the source. So this is the music instrument. If you are located at 2 meters away from the music instrument, then you listen to the sound to be Li equal to 80 dB. If you increase the music instrument to 76 units, so you have 76 music instruments now, what will be the changes to the sound intensity level? You might think the new sound intensity level is equal to 80 dB multiplied with 76 units. We cannot do this because the sound intensity level is non-linear. So you can see decibel cannot be added up directly because it's non-linear representation. Therefore, the new sound intensity level for 76 music instruments is not equal to this. In order to solve this problem, we need to convert the decibel unit into a linear scale. So how can we find the sound intensity, which has the linear scale in watt per meter square? Since we know that the sound intensity level is equal to 10 log I divided by the reference intensity, where the I0 is equal to 10 to the power of negative 12, and Li is equal to 80 dB, by rearrange the formula, we can obtain the sound intensity. So we divide the 10 here, so this gives you 8. Log, you move to the left hand side, you obtain 10 to the power of 8. And then I0 here, move to the left hand side, you need to multiply with 10 to the power of negative 12. This gives you 10 to the power of negative 4, which is the sound intensity for one music instrument. For the 76 music instrument, it will produce 76 multiplied with the sound intensity. By doing that, you obtain 76 multiplied with 10 to the power of negative 4. So this is the total sound intensity when you have 76 music instruments. Then you can continue to find the new sound intensity level by using this formula. I new now is equal to this value, and I0 is equal to 10 to the power of negative 12. So after you substitute it and compute, you should obtain the result to be this answer. If the question asks you to solve the answer closest to 0.5 dB, then for this case, it is approximate to 99 dB. If the answer here is equal to 98.71 dB, then in this case, the answers closest to 0.5 dB is equal to 98.5 dB instead. So you can see that we can add up the sound intensity because it is linear scale. First of all, we convert the sound intensity level into sound intensity by using this formula. And you should obtain this answer. And this is the sound intensity for one music instrument. For 76 music instruments, you can just multiply with 76. So this is the new sound intensity result for 76 music instruments. Then by using this formula, we can convert the sound intensity into the sound intensity level in dB unit. We can also use this formula to compute the sound intensity level for 76 music instruments. Initially, the sound intensity for one music instrument is equal to 80 dB. And if we have 76 music instruments played together, by computing this, you obtain same result as the previous answer. So this is the first approach that you learn about the decibel addition. As you can see, the calculation is long, where you need to convert from dB to I and from I to dB again. Although we can use the formula here to simplify the calculation, This formula is not applicable when we need to add up several sources with different dB values. So this is the main limitation for the first approach. In the second approach, we can add up the decibel by using this table. First of all, we need to compare two dB values. If the value between them are differ by this number, we need to add the corresponding dB value to the higher number. Imagine that you have 4 sound sources in this case. You can see the dB value are different for this source. The difference between the two sources here are equal to 7. Based on the table here, we need to add 1 to the higher value. Therefore, add 1 to the 42, you obtain 43. The difference between the next two sources is equal to 1. Based on the table here, we need to add 3 to the higher value. So we add 3 to the 43, you obtain 46. The difference between these two dB is equal to 3. Based on the table here, we need to add 2 to the higher value. So add 2 to the 46 give you 48 dB. In this example, assume that you are listening to these 4 music instruments. When the music instrument 1 is playing at this location, the sound level that you are listening to is equal to 34 dB. When the source 2 is playing, then you listen to 42 dB. Source 3 give you 43 dB and source 4 give you 42 dB. How about if all the sources are playing together at this location? So in this case, we cannot add it directly because dB is non-linear scale. So this is incorrect. We have learned the table approach in order to find the total dB. So this is the sound level that you are listening to when all the music instruments are playing together. For the second approach, which is the table approach, we can add up the source with different or various dB, but this can be done in a very slow manner. In order to improve this, let's continue for the third approach. We are using this formula to add up the decibel directly. The total of the sound intensity level or the sound pressure level can be added up by using this formula, where you can substitute the sound level for the first source, second source, and so on. Let's solve the previous problem by using this formula. So we can substitute L1 equal to 34, L2 equal to 42, and L3 equal to 43, L4 equal to 42 inside the formula. Then we obtain the total sound pressure level equal to this answer. If the question asks you to provide the answer closest to 0.5 dB, then you need to check whether this answer is closer to 47.5 dB or 47.0 dB. So in this case, 47.5 dB is closer to it. Therefore, this is our final answer. This approach is more accurate and efficient compared to the previous decibel addition methods. Therefore, please make sure you master it. We can perform decibel subtraction by using this formula. In this problem, we measure the source 1 equal to 42 dB. So in the table you see for the source 1, the sound pressure level is equal to 42 dB. Then we turn off the source 1 and the background noise is measured to be 32 dB. Therefore, you obtain this information. What is the actual sound pressure level produced by the source 1 only without consider the background noise? So we can substitute the source 1 to be 42 inside and your background noise to be 32. After you compute it, you obtain this value, and this is the actual sound level for the source 1. This typo here, it should read L1 only. Please correct it. This formula can be used to compute the decibel averaging, where you see the similarity of this formula with the decibel addition. So without the n here, then this will change to L total, which is the Decibel Addition formula. This example is similar to the previous problem. So in this case, you are going to compute the average sound pressure level. The average sound pressure level is equal to this formula, where your L1 is equal to 34, L2 is equal to 42, L3 is equal to 43, L4 is equal to 42. So after you perform this calculation and consider the answer closest to 0.5 dB, you should obtain this answer. Previously, you obtained the L total to be this value, since the L average is equal to the similar formula but divide with N, which is the number of source. You need to be careful. You need to perform the calculation inside here, only you take the log. To simplify the calculation here, the division here can be converted to subtraction. So minus with 10 log and N here give you the same answer as well. In simple, to find the L average, you can just take the L total minus with 10 log N. So you have compute the L total previously, substitute inside. N is equal to 4 in this case because you have 4 sources, therefore minus with 10 log 4. So the final answer will be equal to 41.3. And the closest answers to 0.5 dB is equal to 41.5 dB. So you obtain the same answer here. In alternative, L average is equal to the L total minus with 10 log N.